southern of Anatolia.
Yeah, east of
Anatolia. So he's going to present earthquake for you. Welcome.
Yes, hi everyone. As my friend said, my name is Bilal Selçuk. I got my primary education from Mardin. Then I went to Diyarbakır. I studied in Nevzat Ayaz Anadolu High School, which is in Diyarbakır. Now I'm still studying at Melikşehir University in Civil Engineering Department. I'm in the second of this section. In my hand is a topic which my topic is the earthquakes. You know, earthquakes is the topic of geology. Before I enter my presentation and my topics, I have to talk about the outline of my presentation, some rule of my presentation. I don't want anyone cut my speech, interrupt my speech when I present to you, when I give information to you. And I guess everyone have paper and pen or pencils. Probably when I present my topics to you, you will have some question about that. Please write your question and wait. After I finish my presentation, you can ask to me. I hope I will answer that. So the outline in my presentation duration will be like 20 minutes. Before I enter my topics, I have to talk about some topics which related with my topics. I mean in geology, course in geology's topic. Which are the plate tectonics and some layers of the earth. Let's start with plate tectonics. Plate tectonics, as you see, the shape of the earth 14 years ago was like this. Then with time, these plates separated from each other. As you see, there is some line between these plates, some boundary, some line between these plates. With time, these plates separate from each other, and South America, for example, comes down. North America went to here, and Eurasia plates went to here. Before this separation, I want to talk about these lines. There is a friction between these plates from each other. Geologists are called for these lines faults. In Turkish fay hattı. You know, there are some visitors here. I want to give some information in Turkish to turn off my presentation in Turkish to everyone understand me. Teacher, one, I have to mark. No, done. And you know, you already learned something from the high school, from chemistry course. There is one popular graph like this, activation energy graph. It's like this. Yes, this one like maximum activation. This one is my maximum activation energy point. As I said, there is a friction between two plates. I called faults for these lines, and I can say for this friction is energy. When energy increase comes to here, after this point, the earthquakes happen. Yeah, as you see, there is a magma under these lines in deep of some layers of the earth, and the magma has a very big temperature, very big energy. This magma causes this increasing of energy. Then as I said, this energy increasing comes to the maximum reaction point of this graph, and earthquakes after this point happen. Yeah, I mentioned about that. The African plate will come to here, South America will close to here, will separate from each other. Now, before I enter my topic, I have to talk about the layers of the earth, which is in the underground, something like this. Let me draw the shape of the earth so you can understand easily. For previously slides, I can say it was in my case of the fundamental of the earthquakes. For layers of the earth, let's draw like this. This one is my earth, and this one is the layer. I mean inner core, outer core, and this one is my mantle. Actually, this inner core in the solid form and this outer core in this liquid. Again, this mantle in the solid form. According to some book which I read, according to some research, I can divide it, I can separate this mantle for two layers, which are the outer layer and the upper layer. And this one is my crust which I draw like this. I mean the surface of the earth. It can be my sea, my ocean, it can be my soil, mountain. As I said, magma has big temperature, big energy, and this energy every time changes. Sometimes magma extrudes these parts, and then again energy increasing, and then come to here. After this point, earthquakes again happen. This is my second case of earthquakes. So sometimes this magma can find some line and comes to surface of the earth. Can be volcanic mountain, can be under the ocean, under the sea. It can be volcano. When magma comes to surface of the earth, we are called for this magma is volcano. Yes, as you see, there's a magma under the mantle, and it extrudes the mantle. Then sometimes it causes crack of the plates, soil. Then the earthquakes happen. They are the result of the sudden release of the energy in the Earth's crust. This creates seismic waves of energy that travel through the Earth. Yeah, you are seeing this guy, and he applied some forces on this wood. Then the energy of this guy, which applied on the wood, increased. Then it caused break of wood. The case of the fundamental main of the earthquakes like this. We can think like this for earthquakes. And as you see, before and after, it caused some cracks, some line. Then earthquakes happen because of changing of energy, increasing of energy. Yeah, I mentioned about the fault. We don't know what's the P wave, what's the S wave. Let's talk about these waves of the earthquakes. Yeah, think about there is a water in my left hand and there is a rock in my right hand. If I drop rock on this water, it will cause some floods on this water. Think about, let me go here. Now I will rotate my water. I will put on the whiteboard. Again, this one again is my water. I rotate and I will draw like this. And this one again, my rock. If I throw my rock, it will cause some flood of the water like this. This one is the center of the earthquakes. Some books says epicenter for this issue, this thing. And this distance is the frequency of my waves, my earthquakes, and the number of these layers is my magnitude of my earthquakes. Continue. I think, no, comes to previously slide. I think everyone tried this experiment when you were a child. I guess everyone dropped one rock to the sea, maybe back, some place of the water. I have to see it caused some flood of the water. It's same with the behaviors of the waves of the earthquakes. Yes, for P waves, think about one spring and one guy. If I keep this spring and if I apply like this, my force will goes from A to B. It's my direction. I need my direction with turning motion. And think about this one is my P wave of the earthquakes. And this rock, again, if I keep this rope, I apply force onto this rope like this, it will go from A to B. Again, I mean my direction from A to B with jumping motion. According to this slide, I can command like this. Yes, if my surface of my earth, I mean soil, maybe my building, can jump, I can command like this. The shaking of the formation of S wave is bigger, way bigger than the formation of the P waves. Yeah, as I mentioned about that, you see this one goes in turning motion from A to B, and this one P wave, and this one goes from A to B with jumping motion. This one is my secondary wave. Basically, when earthquakes happen, it has center and seismic wave, like radio and cell phone wave, which has frequency. When earthquakes happens, primary wave comes first. After that, I mean, from the center of the earthquakes to my building, primary wave, P wave, comes first to my building. Then secondary wave comes from the center of earthquakes to my building, my place. Yes, this one, as you see, the center of my earthquakes. There is a fault from two plates. It can be transformed convergent and divergent fault. You already know from the geology course. I don't want to talk too much about this fault, type of faults. So this again, this one, just know this one center of my earthquakes. The principle of waves. For this slide, I mean as I said, the P wave comes to my building, my house, from the center of the earthquakes. Then, after P waves, secondary wave, we call S wave, comes to my building from the epicenter of the earthquakes. Yeah, before and after. There are some tectonic plates, and there is one line on boundary which has a big energy because of magma between two plates, and again the energy increased and it caused the shape of changing shape of this field. After and before earthquakes when happen, it can be like this: transform, convergent, and divergent. Scale of earthquakes. San Francisco in 1906, one big earthquake happened, and these earthquakes caused too many deaths of the peoples. After these earthquakes, one guy tried to create one scale of the earthquakes. Charles Richard, and now, as you see, he's on the one mission, and he did something. This machine is seismograph. We measures the magnitude of the earthquakes with this machine, and scale of earthquakes created by this guy who lived in San Francisco. After San Francisco earthquakes happened, he controlled some line of the earthquakes which happened, some distance between before and after, and he creates one scale. Every country which are in the world except this scale of the earthquakes, I mean magnitude of the earthquakes. Yeah, according to some situation, not here, small, strong, major, according to scale of this guy. He measures magnitude of the earthquakes with seismograph, and we comment like this. And seismographists can use this machine, who can use the seismograph. The earthquake map of the Turkey. Don't worry, you are in the same place. We are in the Kayseri, we are in the same place, and there are two type of big faults of the Turkey, which are the east is Anatolian faults and the North Anatolian faults on the map of the Turkey. These faults causes the big earthquakes. Continue. Again, same thing on the map of the world. Commonly, earthquakes happens on these lines. Chile, I don't know the name of this place. Something like this. Yes, you will be a civil engineer, and you will be faced with this issue. Earthquakes issue. We have to create some solution, some observation solution for earthquakes. Maybe after you graduate from the university, you build some towers, some bridges. When you establish and you build our building, maybe we have to think about the observation solution of the earthquakes. As you see, this is my building, and this place empty. Between foundation of my building and surface of the earth, I mean soil, there are some stuff. This next then you can zoom it, you can control this. This one is the observation stuff of the earthquakes. It can be rubber, it can be table shake of the earthquakes. Continue. Yeah, this one is the rubber. I'm showing this rubber. There is some plates, some steel plates. When the earthquakes happen, it behaves like this. You know, rubber, you cannot cut rubber easily. Rubber can absorb some shaking of the earthquakes. So it behaves like this, and with this motion, it can absorb, isolate the shaking of the earthquakes. Continue. Yeah, as you see, this one is the foundation of my building. I mean, the under basement floor. Between this place and the surface of the earth, there is the rubber observation stuff of the earthquakes. It can carry too much tons, and when earthquakes happen, it absorbs the shaking of the earthquakes. I think I have one video about this stuff. Japanese scientists already create some observation solution for earthquakes. Let's watch. After video, my presentation will be finished. If you have some question, you can ask me. And before we watch video, I have to talk about my references: Wikipedia, Google, and Essential Geology book. One small video. Size of my video is too small.
Is the leader in seismic isolation, with over 250 building and bridge projects.
Everyone can hear this. Yeah. Okay. Let me start from the beginning.
DIS is the leader in seismic isolation, with over 250 building and bridge projects completed to date. As you see here, earthquakes caused considerable destruction to not only the structure, but also its contents. The shaped table demonstration shows a building model that is not isolated. There is considerable damage to the contents. The same building is now isolated from the shaped table and experiences much lower acceleration. Its contents are unaffected by the ground motion beneath it. The isolation system consists of 33 lead rubber isolators and 54 elastomer back sliders. The isolators and sliders were tested at earthquake velocities at the University of San Diego. The tests for this project were significantly beyond code requirements. Each isolator was subject to a series of 10 maximum credible earthquakes. Maximum average corner displacement obtained from the 7-time history analyses is 30 inches for the maximum credible earthquake. The maximum corner displacement of any earthquake is 38 inches. The 45-inch test was conducted to demonstrate the reserve capacity and robustness of the isolation system. The test machine has a vertical load capacity of 6,000 tons, a lateral load capacity of 1,000 tons, and a lateral displacement capacity of 48 inches. It is also capable of lateral velocities of up to 70 inches per second. The machine's capabilities were fully utilized in performing the tests and the time history earthquake records shown here.
Yes, everyone. My presentation finished. If you have some question, you can ask me. Does anyone have a question?
The building you showed that was empty, right? That's some rubber in.
Yeah.
How can you sustain the mechanism of sustaining the earthquake?
You know, between surface of the earth and my foundation, there are some stuff, and this stuff can carry the weight of my building, and there is some rubber in the inner. This stuff, when the earthquakes happen, it can absorb this shaking. You understand what I mean?
That means when it comes, is it? What do you mean?
No, it can rotate to everywhere. It can rotate to everywhere, then it can absorb my shaking of earthquakes.
Yes, I have a question. Here we talk about the P wave and the S wave.
Yeah.
I want to know the P and the S from what they stand for.
I couldn't hear
The
you.
P and the S
Yeah.
from what they stand for.
I couldn't understand your question.
The meaning of the P and the S.
Primary and secondary. You know, I demonstrated to you, primary wave from the epicenter of the earthquakes comes to my building first. That's why we call primary wave. After that, secondary wave from again epicenter of earthquakes comes to my building. That's why we call primary and secondary wave. Is there any question? Okay, actually I try to give correct true information to you. I researched so much about my topics. If I made some mistakes, I apologize for that. Thank you to you listen to me.